Hello, dear young minds. We have reached at the video Gravitation 09. All right. So, in this video, we are going to discuss about this concept of density. What is this density, and what are the applications of Archimedes principle? All right, you must have heard about this Archimedes principle, right? So, if you don't know what is Archimedes principle, then go back to 7th video, Gravitation 7 and Gravitation 8. Learn about the concept in 7th video. In the 7th video, I have explained what is Archimedes principle in detail, and in the 8th video, to clarify the concept and to solidify the concept, I have solved some numericals. All right, you can type Gravitation 7 from PhysicsPoint by Shrikant Bashetti, or you can type Gravitation 8 from PhysicsPoint by Shrikant Bashetti. Then you are going to get this concept and numericals. Go through that, then come to this Gravitation 9 so that you feel more confident in watching this video. My name is Shrikant Bashetti, and I welcome back all of you to your beautiful physics channel, PhysicsPoint, and let's get started. The first thing is density. What is the meaning of density? We need to understand. Okay, the symbol for density is going to be rho. Okay, so this is known as rho. So let me write it here. This is rho. This is a Greek symbol. We have different symbols. No, we have something like A, B, C, and this is a Hindi letter then afterwards we have something called E. We have all these letters, no? So like that we have some symbol that is called as rho. All right, so fine then. So what is this density? Density, we have a very simple definition, that is like mass per unit volume. What is this? Mass per unit volume is known as density. Now you must be wondering, what is this volume? The meaning of volume is how much space is available. How much space is available, that is only known as volume. So simple definition you can write, that is rho is equal to mass divided by volume. This is the formula for that. And if you go for the unit, so what will be the unit of this density? The unit is going to be, mass is kg and volume is meter cube. So unit is kg per meter cube. All right, now one more thing, what is the feel of this density? Okay, let us take feel of that. For example, I have one container here, or one box. Okay, same box I have here. Okay, two same boxes which have same space. So inside, so whatever inside space is there, it's the same. I mean, here also same space is there, and here also same space is there. All right, so let us take that volume to be, it can be anything, no? So this volume is like, for example, 1 metric cube. Okay, this volume is also 1 metric cube. So what is the meaning of 1 metric cube? I will come to that also. Now in this, if you fill iron, okay, you are filling iron fillings, iron objects. Okay, you are filling the objects made up of iron. All right, so what is this? This is iron. Now if you fill the cotton here, okay, what you are filling here? You are filling the cotton. Okay, here is cotton, the same space. Okay, so here is the cotton. Now if you hold both of this, if you hold this and if you hold this, which one will feel more heavier? Please tell me. Definitely this thing will feel more heavier, no? Yes or no? It feels more heavy, and definitely this is going to feel light. So what does it mean? It means, I mean, in 1 meter cube of this space, and or in this 1 meter cube of space, here maybe you are accommodating how much mass? Maybe let us take this is like 20 kg. Just an example, okay? 20 kg of iron must have been filled. Just an example. All right, I'm not saying in 1 meter cube 20 kg of iron will be filled. No, I'm not saying that. And in 1 meter cube of space, how much cotton you may be filling? Maybe let us take it as 2 kg only. All right, are you understanding my point? If you take iron, so if you take the case of iron, what will happen here? In the case of iron, if you do mass divided by volume, how much it will be? Mass is 20 kg and volume is 1 meter cube. So 20 by 1 is 20. So 20 kg per meter cube. What is this? This will be the density of iron in this case. Once again I am repeating, I am not saying that the density of iron is 20 kg per meter cube. I am just giving an example. Now if you take the case of cotton here, if you are talking about cotton, again the density will be mass divided by volume. So how much is the mass? Look at this. This is 2 kg. 2 divided by what is the volume? 1 meter cube. So it becomes 2 kg per meter cube. Alright. So in 1 meter cube of space, how much cotton we can accommodate? We can fill 2 kg of cotton. In 1 meter cube space, how much iron we can fill? 20 kg. All right. So density is nothing but how much heavier you feel. That is the meaning of it. And basic definition is mass per unit volume. You can observe here also how much mass you can put in a given volume. All right. If you go mathematically for this, so what is this rho? Rho is equal to mass divided by volume. That formula is there. There is no denying of that. All right. Now, if you want to increase the density means, what are the two ways? First, you have to choose the material with more mass, which can be held in less volume. All right. If you are able to fill more mass in less volume, you are going to have more density. Definitely the density of iron is going to be greater than density of cotton. Why? What is the reason for this? Because you can fill more mass of iron in less space. But here you cannot fill more mass. In less volume. It is not possible. This situation is not going to be possible in cotton. All right, are you understanding my point, what I am trying to say? So basic feel of density is you have to fill more mass in less volume, then the density is going to be more. All right, so let me give you one more example here. For example, let me go to the other page. Now here 1 kg of iron is there. 1 kg of iron and 1 kg of cotton. 1 kg of cotton. Which one will feel more heavier? Don't say that iron is going to feel heavier, because both are 1 kg. This is also 1 kg and this is also 1 kg. Both will have the same downward force. They will experience the same downward force, like this will experience the force like mg, that is like 1 into g. 1 into g is nothing but 1 into 10, that is equal to 10 Newton. And this will also experience downward force, that is weight is like 1g, right? 1g as in mg. M is 1 kg here. So 1 into 10, it is also going to experience 10 Newton. So weight of both the things is same and both are going to feel in the same way. How much heavier we are feeling the iron? No, we are going to feel the same heaviness in cotton also. But the only difference here is to accommodate this 1 kg of iron, maybe this much space is more than enough. This much space you can hang it like this. Okay, have you seen this stone of 1 kg in the market and all? Maybe this much space is more than enough. But for this 1 kg of cotton, you need this much space. Look at this, maybe more space than this also. To accommodate 1 kg of cotton, definitely you need more space. Look at this. If you observe here, so here both the side mass is what? So both the side mass is like 1 kg in both the case. How about volume? In this case, volume is like small. Correct, no? Volume is small. Let us take, for example, the volume is like 1 meter cube. Just an example I am taking once again. And here, what is the volume here? The volume may be 10 meter cube here. Maybe it is bigger, no? Look at this. This cotton thing, whatever bag we are using, whatever the container we are using, whatever space we are using, it's going to be more. All right, now if you go by the formula of density, now here in this thing, so what will be the density? Density is equal to mass by volume. What is the mass here? 1 kg. What is the volume here? 1 meter cube. 1 kg and 1 meter cube. So 1 by 1 it becomes, so 1 kg per meter cube. Just an example it is, to make you understand about the density. Now if you come to the second case, so what will be the density here? Here the mass will be 1 kg and volume will be 10 meter cube. So 1 by 10 is 0.1 kg per meter cube. All right. So this is the density of this cotton here, whatever I have filled. All right. So basically density means, once again I am repeating, if you want to have more density means you should be able to fill more mass in less volume, then only we are going to have more density. All right, fine then. Going back to the not going back going forward to the next thing. So already the concept of density is clear. Density is equal to mass divided by volume. Let me give you one more example. I mean, you must be thinking this nail is there, no? So this nail is going to sink in water. Sink in water. The nail will be sinking in water. Ships, they are also made up of iron. Nail is also made up of iron, and ships are also made up of iron, but nail are going to sink in water, but ships are designed in such a way that they float in water. Okay, they float on water, you can say. How it is possible? What is the reason for this? All right, so there comes the buoyancy, Archimedes principle, everything. So let's move forward to understand all those things. All right, now look at this. This nail is there, no? You can observe the nail here. This nail is sinking, but this ship is there, no? So it is floating. The reason is quite simple. It's quite simple. The straightforward answer is that density of nail is greater than density of water. All right, so if any material is having density more than the density of water, definitely it will sink. Please make a note of that point. If density of any matter is greater than density of water, means it will sink. Very, very important point. Please make a note of this. It is going to sink. All right, if density of any material, it may be ship, it may be anything else. So if density of any material is less than the okay, this should be density of water, I'm sorry. So actually here it should not be density of ship, it should be density of water. All right, so if density of ship is less than the density of water, definitely it is going to float. All right, please remember this. So what I have told now, so I have told you like, so if density of any material is there, if density of any material is less than density of water, so what will happen here? It will float. The density should be less than water. If density of any material is greater than density of water, it is going to sink. All right, please make a note of this. I'm going to rub this off because here I am going to have some more images. Once again I am repeating here. So this density of nail is there, no? This density of nail is more because it is tightly packed in a small space. More mass is accumulated. That means its density has become more. That's why it is a sinking. Now here in this ship, mass is more, we know that, but it is distributed over large space. Look at this large space. This boat or ship is this is small boat, but ships are very big, right? So it is going to be spread over a large amount of space. Just imagine this nail is there, no? So if you beat this nail, this nail can be converted in the form of a sheet like this, no? Okay, big sheet, aluminum sheets and all, the aluminum foils and all they form, no? So if you make a big sheet like this and if you put it in water, don't you think it is going to float? Why it is going to float? Because you are going to distribute the same mass in a large volume. You are going to increase the volume. You are increasing this space. Look at this. By beating this, by converting this into a sheet, you are increasing the volume. If you are increasing the volume, means the density will come down. Because what is the formula for density? Density is equal to mass divided by volume. Are you understanding my point? If volume is increasing, means the density will come down. If density is coming down, means definitely it is going to float. Not this way, definitely this way it is going to sink only. This nail is going to sink only, but the nail in this sheet form, it is going to float. All right, so let's move forward. So we have to look at applications of Archimedes principles. What are the applications of this Archimedes principle? The first famous example is floating of ships. This is the first one. All right, so you must be wondering such a big ships, how they are going to float. Now look at this. First and foremost reason is that these ships are very big. First of all, the density of this ship is made in such a way that it is always less than density of water. It is not solid like nail, no? So if you take nail, so that nail is solid. Okay, all material is there inside, but inside this ship, whatever ship you are taking here, inside this ship, empty space is there. It is not that it is filled. So what is there inside this ship? We have empty space. Okay, it is occupied from air. All right, empty space is there, This is the first reason. That means the density of ship is less than density of water, first thing. And second thing, I mean, more space is made available at the bottom. Look at this. It is going to experience the buoyant force from everywhere. Only front part is shown here. Other parts are not shown here. So more space is available at the bottom. So it is going to experience more buoyant force. The buoyant force what it is experiencing is very heavy. So as a result of density of ship is less than density of water, and it is experiencing more buoyant force, so it is going to float. All right, fine then. So let us make points of that. The ships are designed such that overall density of ship is less than density of water. That's what I told you. And second thing is more area is exposed to water at the bottom, so that it experiences a large buoyant force and continues to float. If you draw the free body diagram of that ship, for example, this is the ship, means I mean the weight will be acting like this. The weight will be like this, and buoyant force will be this much. Look at this. This buoyant force is more. The buoyant force magnitude is more, and this weight value is less. So that's why as buoyant force is greater than the weight, it is going to float. This is one reason. And another reason is its density is made less than the density of water. All right, now you must be wondering, then why do some ships sink in water? Sometimes they are going to sink, so what is the reason? So we have this famous example of Titanic, right? So you must be knowing about a Titanic ship, right? So Titanic ship, it was very big. It was designed to carry so many people, luxurious ship. But why did it fail? Why did it sink? The Titanic sank, why? So the reason is, I mean, there was some dashing with this iceberg and all, no? So some water entered into this ship. Water entered. So whenever water enters into this ship, no, the entry of water, whenever water entry of water, what will happen? If water is entering, means the mass will increase. If mass is increasing, means density will also increase. If density becomes greater than density of water, then definitely it is going to sink. That is the main concept here. All right, so that's what I have written here. So what is that? When water enters into the ship or boat, mass increases and hence density increases. All right, so when density is more than the density of water, then ship sinks. The Titanic did not sink immediately. It took time, right? So water is filling. So whatever water is there, so this water will start to fill. So when the density of that ship, total ship, including mass of the water, everything, so density of ship becomes greater than the density of water, it starts to sink. All right, so it is coming back to the same point again. So what is that? If density is greater than density of water, the body is going to sink. Look at this. If density of any material, for that matter, if it is greater than density of water, the body sinks. If density of any material or any matter is less than density of water, means the body is going to float. All right, I hope you can remember this and you can answer why the ships are going to float, or sometimes why they sink and all. All right, fine then. Moving forward, the second application is about submarines. What is this? We are going to discuss about submarines here. I mean, what are these submarines? Just to give you a simple definition, submarines are water bodies. I mean, they operate in water, which are designed to float on water and to submerge in water as per the needs. Very interesting, right? So they can float also and they can sink also. Both the things they can do. Just to show you an image, this is the submarine. Look at this. This is floating right now. Submarines are very big, okay? So these are used in navies for defense purpose, for attacking purpose, and these can be used in tourism also, and going underwater and studying marine life. So for all that we can use. So this is floating here right now, and it can go inside also. Now it is inside the water. Look at this. Inside the water. It can go inside the water and it can float also. In both the ways it can operate. That's why it is called submarine. All right, fine. So just to show you, I mean, how it operates. Look at this. Now it is above, right? Look at this. It is it was above. Now it went. It is submerged here. It can submerge itself, or it can come onto the top of the water and it can go. Usually it goes. All right, so this can be used for attacking also. Look at this. We have one periscope also here. What is this periscope? We will study now. Look at this. Look at this bomb, how it is attacking. All right, so this can be used for attacking purpose, for tourism purpose. I will come to uses of that. See, look at this. Okay, missile is released from there. So many things are there. You in World War, these submarines played very important role in deciding who will win. Okay, because underwater, if you are there, if you are doing your operation underwater, then the enemies won't get to know where you are, and easily you can attack them. All right, so this is how the submarines are working. How it is happening? Why they are able to sink? Okay, why they are able to go to the surface? Okay, up to what level they can go? So all that we'll see, and what is the mechanism, how Archimedes principle is helpful, we'll see that. All right, look at this. These submarines are there. No, these will have two tanks. Okay, one in the front and another in the back. Okay, so these tanks are called as ballast tanks. What are these are called as ballast tanks. Now if you fill water in this ballast tank, fill water. Okay, if you are filling water in the ballast tanks, what will happen? The mass of that submarine will increase. If mass is increasing, means density will increase. The density is increasing means when density becomes more than density of water, it is going to sink. Submerge. Sink as in it won't get destroyed. Now that will be controlled, right? Now when you remove this water from the tank, okay, we have two big tanks. Okay, one in the front and one in the back. This will be maintained from the submarine engineers. If you remove the water, what will happen? Mass will decrease, then density will decrease, then definitely it is going to float. All right, I hope it is getting clear. Now to show you that mechanism, look at this. This is one schematic diagram here. Now what is happening here? Now water is filling. Look at this blue color they are showing here. No, so water is getting filled here. Okay, whenever water is getting filled here, so it is coming down. Now it went up. Why? Because water is removed. Right now it is it has started to come down. Look at this blue color thing is water. It has come down because we filled water, mass increased, density increased, and it sinked, it submerged. All right, now it is submerged. Now look at this. Now water is removed. This water is getting removed, blue color thing. So it went up. So when we remove water, the mass will decrease, the density will decrease, and it is going to float. So how it is going to be done and all, so that that is known to the marine engineers, and more about that you can study. Okay, in YouTube you can see so many videos, but this is how generally it works. All right, it works on this ballast tanks. All right, why two tanks are provided, one in the front and one in the back? To maintain balance. Okay, to maintain the balance, so they have been provided with two tanks. I hope the concept is quite clear. Fine then, so let us write all of that. So whatever we have discussed till now, so what is that? How do they float and submerge? The first point is they have two tanks, one in the front and one in the back. All right, so these tanks are called ballast tanks. Okay, that is also clear. These ballast tanks control the buoyancy of the submarines. Okay, buoyancy means when they will be floating, when they will be submerging. So all that will be controlled from these ballast tanks. All right, and what are the uses of these submarines? Uses are like these are used for marine science. Marine science in to study about marine life. Study of marine life. Study of marine life. So what are the different species available? Okay, what is their behavior? What is their food habits? All that. To study that they can be used, and they can be used for exploring deep waters. Okay, through scuba diving we can do the exploring of deep waters, but wherever we cannot reach there, we can take these submarines and we can study those things. All right, and they can be used in navy for to attack neighboring waters and for self protection. For all that we can use them, and they can be used for this tourism also. All right, to see the marine life and to show anything underwater, to study anything for tourism also they can be used. All right, fine then. Moving forward, so one more important use of Archimedes principle is lactometers. Okay, so these lactometers are used to measure the purity of the milk. All right, so these are used, you must have seen them in the dairies and all. So these lactometers are used to measure that purity. All right, and there is one more thing called hydrometer, and they are used to measure the density of any liquid. All right, I don't want to get into details of both the things because these are again we have to explain how do they work in a separate video. If you want them, I will I mean make them, but right now in this video I am not going to discuss about lactometers and hydrometers. I hope the concepts are quite clear. The first application is a floating of ship, and why it floats I have already given the detail. And second thing is submarines, I have explained in detail about submarines. And third one is a lactometer. All right, so to measure the purity of milk. And fourth one is a hydrometer, which is used to measure the density of any liquid. In exam, if they're asking, just write all this, and explanation means go for the explanation also. And I have discussed about density also. Density is equal to mass by volume. If density of any material is less than density of water, means definitely it is going to float. If density of any material is greater than density of water, means it is going to sink. So this was the main highlight of this video, right? So the main highlights were these things only. All right, then thank you very much. Have a good day, and make it sure that you are liking these videos, sharing these videos, and don't forget to subscribe to the channel so that it reaches maximum number of people. Thank you very much. Have a good day, and bye bye.